Okay, so we'll look at palindrome permutation today. Given a string S, return true if a permutation of the string could form a palindrome. What is a palindrome? It's a string that reads the same forward and backward, and false also otherwise. Okay, so it's pretty straightforward, right? So go to the example. S code false. Why? I mean, it's just impossible to get a palindrome by these four letters, right? You can't. Simply can't. AAB. Why? It's true. Okay, so first it's true. Why? Because we can make it as ABA, right? And this way, it's a palindrome. Read forward, ABA. Read backward, ABA. Exactly the same. The third one. Okay, this is a little bit long. So CAREARAC. All right, so it's actually itself is already a palindrome already. We don't need any permutations. So looking forward, right? So C, which is exactly as C, A is exactly as A, R is exactly as R, and E is in the middle, which you don't need to find any other letters to form a palindrome because itself is a center. We don't really need that. The length is in odd, is odd, but if the length is even, which is quite important in this case, so let's say AB. Okay, so the length is even. So what is a palindrome, right? Two ways. So ABBA, or we could do BAAB. These two ways are palindromes for ABAB. All right, so what should we do for this question? Okay. Well, likely to use gonna use a hash map, right? Why we want to use a hash map? Well, since actually what's the observation that we find from these three examples? Since it's a permutation, right? We allow permutation. So what's the real core idea of determining if the if the string can be formed a permutation? Well, actually, the core idea is there are two scenarios that we know is a palindrome. Two scenarios. First scenario, if there is a single letter plus everything else, so everything else are even. I mean, the appearance of the rest of letters is even. So which means, like here, A is a single letter, which is odd, but A and A appears twice, so it's even. Another scenario, which is like this. So the total number of letters in the string is even, and all these letters appears in even times, which means it's at least twice or four times or six times, and so on. So all of the letters appear in even times. Okay, two scenarios actually, because we have the ability to do a permutation. Okay, so what's the first step? The first step is always to form a hash map. So we want to import, import. What do we want to import? So import from collections, import default dict, right? So here we just use default dict directly because I don't want to deal with the scenarios when adding when there's like, let's say when the elements the appearance of the elements A is 0, then directly adding the value in the of the dictionary is not permitted. So we need to do a lot of handling. But default dict would allow us to do it directly because it will handle it inside. So we don't really need to deal with ourselves. Okay, so we want to define a default dict, right? So let's call it frequency default dict, which is what we want to store here is the int. How many times does it appear, right? So it's int. Okay, so let's go through a iteration for this string, input string, which is s. So for characters in s, okay, so frequency of the character is gonna add 1, right? So each time we find a new letter, we just add 1 directly to the frequency. Okay, so now we maintain a hash map. We know exactly many times for each different letters that appears in the string. So what else? The next one is determine if it's valid, right? So first we'll have a odd is 0, which means the number of appeared odd, the number of characters that are appear in odd times is 0 in the beginning. So it's a initialization. So for character in frequency, because frequency stores keys as characters as keys. So for characters in frequencies, what we do here is if frequency at C, right? So the number of appearance for character C is what? It's not even, right? So if it's not even, which means it's going to be modulo as modulo 2, and it's going to be 1. If that's the case, what we should do is odd plus 1. And we'll do this entirely. So after the iteration, then we'll find that then if we'll just know like how many odd appearances do we have for the characters, right? So what we do here is return if the odd is 1. Oh, sorry. So if the odd is actually less or equal to 1, because as we see, two scenarios. If there's no odd, and if there's only one odd. So if there's like less than or equal to 1 odd, then it's true. The else conditions is going to be a false because apparently there's going to be more than 1 odd, and we don't allow that. Okay, so let's test. Okay, good. All right. So after this, what's the runtime? Runtime, 2 for loops, and iterating this one is iterating the length of character input string, and this one is the frequency of the unique letters. So overall, it's going to be a big of n. What about the space? So we have a frequency the hash map to store, and also a big of n because the length is the same as the unique letters, which is going to be smaller or equal to the length of the input string s. And this one, frequency, we don't really store anything. We just have one single odd, like kind of a cap. So it's a kind of sentinel value. So this is just only one single value, which is big of 1. But overall, it's still a big of n. All right, thank you so much.